Or guess we record second hour because fourth hour gone. So if you weren't here yesterday, hopefully you won't have trouble picking up. When we started with this net change term says that the integral a to b of f prime of t dt is f of b minus f of a, and that gives us what we refer to as the displacement of an object if we're thinking about velocity and position. If we want total distance, then what we do is we take the integral from a to b of f prime of t dt. That's going to give us the distance if we do the absolute value. So distance is the absolute value. Displacement is just the integral of the rate function. Okay. There's one other piece here that's kind of cool that we want to know as well, and that's the mean value of a function. So if I have a function over an interval a to b, you can see it has a height there, and has a height there. The question is, what's the average height of the function, or the average value of the function? Well, you tell me when you think I'm at what you would consider maybe the average height of the function. You tell me when to stop. Okay. Yeah, kind of hangs out at around that height for quite a long time. So maybe that's the average height of the function right there. We can calculate the average height of the function. It's no big deal. Average height is this. You do the integral a to b of f of t dt. If I just left it like that, what does that give you? What does the integral a to b give you? The area. If you want the average height, all you have to do is do multiply by 1 over b minus a. Or in other words, divide it by the width of the entire interval, and that will give you the average height of the function over that given interval. Okay? Definitely want your calculator today. You can't do today without a calculator. Okay. Okay. So this is where, again, we embark on, I guess, the things that tend to be confusing for people during the course of this unit. Um, you really need to pay careful, close attention what you're being asked to do, because I won't put the questions on the test in the exact same order. Okay. So I was trying to tell this to fourth hour yesterday. Do well with on the test last year. Okay, so don't memorize, just memorize the process. Make sure that you actually know what you're doing. Find the displacement of the car over the given interval. It says, use your calculator for the following problems. The velocity of the car is modeled by this. So that's the car's velocity. It tells us the speed and direction of the car at any time t, where t is measured in hours, okay? V is measured in miles per hour. Consider v of t over the interval 0 to 4, and let s of 0 equal 10. Anybody know what that means? Let s of 0 equal 10. At time 0, I'm at a position of 10. Yeah, so I told you guys about driving home last night. I was at mile marker 40 when the tow truck had to come get me, okay? So this is saying, I'm at a mile marker 10 when I start out, okay? That's what it's saying. It says find the displacement of the car over the given time interval. Super easy. All we do is we just say the integral of the velocity function dt, okay? And we go from 0 to 4. You don't have to write out the entire function. If you write v of t, it says v of t is 20 sine of pi t over 2 minus 1. I'm going to take that, plug that in my calculator. A lot of people don't plug it into their calculator correctly. Make sure you try to do that. I've got a 20, a sine, pi t divided by 2 parentheses minus 1. Degrees or radians? Radians. I'm going to zoom 6. There's a picture of my sine graph in that window. Now, we only need to see through 4. What's the amplitude of this graph? 20. So if you want to see the entire graph, just go to your window and up your maximum to, let's say, 25. You'll for sure see it all then, negative 25. And then on my x min, I'll go to negative 6, and my y max, or x max, I'll go to 6. I'll put tick mark every 5. And probably get a little bit better graph there. So if we want to find the displacement, this is all I need to do. I'm going to do it on my calculator. So I go second calculate, number 7, 0, 4. What do I get? Negative 4. Now, by the looks of this, it looks like it maybe has equal area above and equal area below, doesn't it? But that's it's just the way that the graph looks. There's actually a little bit more area below, okay? And so we get negative 4. Negative 4 what? Negative 4 miles. So if its displacement is negative 4 miles, where is it currently sitting? At mile marker 6. Very good. All right. Find the average velocity of the car over the given time interval. This is where you got to pay very close attention. Okay. Are we given the position function or the velocity function? So it's wondering the average value of this function. Go from 0 to 4 of v of t dt, and we multiply it by 1/4. 1 over b minus a. Everybody got that? That equals negative 1 what? Hour. Find the total distance traveled the car over the given time interval. How's that different than the displacement? Absolute value. So we do the integral 0 to 4, the absolute value of v of t dt. So I go back to my graph here, going to y equals, and I got to insert an absolute value symbol. I got mine in catalog. I think it's sitting in math numbers as well. So as I look at the graph, hopefully the graph should be sitting above the x-axis the entire time. Sure is. And it bounces around. Okay. And I'm going to calculate on number 7. I'm going to go from 0 to 4. It's very challenging for your calculator to do. There it goes. On the AP Calc exam, I'll show you what you will do in this situation. We have 50.99, and now you have two options. You can either round to the nearest thousandth, which would be 4, or you can simply drop off all the digits after you go to 3 places. So either one of these would be acceptable. Okay? You can either round to the nearest or just cut it off after 3. What's my label? Miles. So that's how much it's traveled, okay? Find the position of the car at 2 hours and 4 hours. Okay. So already asked Lolly. I said, Lolly, if the car has a displacement of -4 and it starts at 10, then what's its position at 4? And you said 6. So the way we find position is this. This is kind of a common sense piece, but we write it out. The position is equal to the start plus the displacement. So we'll do 2 of these. Just find the position of the car at 2 hours. So we would take its position, which is 10, and add to that its displacement after 2 hours. Because at time 0, we're at a position of 10. So I go an integral from 0 to 2 of v of t dt. And that will give me the position of the car after 2 hours. Take out my handy-dandy calculator. I want to run this integral from 0 to 2. Grab number 7. And I get 23.465. Now, here's what I do sometimes in the AP exam. I forget to add on 10. So that equals 33.464. That's its position. In order to do 4 hours, I would take 10 plus the integral 0 to 4 of v of t dt. Yep, we already computed that. The integral from 0 to 4 is -4, so therefore we have 6. Everybody clear on that? Is there any question about that piece? Okay, then let's get slightly more challenging. Find the acceleration of the car at time 2 hours. Take the derivative. Why? Acceleration is the derivative of velocity. So what I need to do is I need to take v prime of 2. This is a problem on the AP exam and on my test where you get to use your calculator. Is there an easy way to take this derivative? What should we press? Second, calculate, 6. When do we want to find the derivative? 2. That's it. It's not supposed to be complicated. You just got to know what you're supposed to do. So we got -31.415 what? Miles per hour. See how easy that was? Or would you like to go back and do the chain rule by hand? Okay. All right, thank you. All right. Noah and Jens love the chain rule. Good for you guys. Show up yesterday. All right. So now here's where the confusion happens. So you guys let me know then, okay, the point at which you get confused, because I'm going to do my best to explain this. I might do a bad job of it. Are you ready? What is the average acceleration over the time interval? This is where it's really, really, really important. Are we given the velocity function or are we given the acceleration function? So notice the difference between these two questions. The average velocity, or when it's asking the average value of the function, we're given the velocity function, right? That's when we do this piece. Are we given the acceleration function? No. The acceleration is a rate of change from the velocity, correct? Here is where we found instantaneous. We took the derivative. What do we do if we want to find, instead of instantaneous rate of change, what do we do if we want to find average rate of change? Okay, we use the slope formula, right? That's all we do. Okay, remember when we started out at the beginning of the year, we were finding rates of change. And we tried to do the instantaneous rate of change, slope at one point. That's what this is. When it says average, that's at 2 points. Okay, so here's what we have. V of 4 minus V of 0 over, as Jen said, 4 minus 0. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. How do we calculate V of 4? How can I do that in my calculator quickly? Table, okay. 4, I get negative 1. And I plug in 0. I get negative 1. Divided by 4 minus 0, and I get 0. I have to have a label, acceleration, miles per hour squared. You have 3 examples in your assignment like this where you use your calculator. You'll want to get used to doing that, okay? Let's flip it over, look at the next one. Yes. I have the velocity function. What's that? Yeah, I took the absolute values off. Number 2, consider the concavity of let RT be a rate function that measures the rate at which snow falls in inches per hour. So we are given a rate function here. That's the first most important thing to notice. Are we supposed to get snow on Thursday night here? Is that what they're saying? Wednesday night? Thursday, not very much though, right? Just a little dusting. Kevin, weatherman? An inch in the UP. Are you going to the UP? You are. Good for you. Have fun up there. All right. Take some pictures. We want to see. All right. Okay. So now we're changing the problem. We're talking about snow falling at a certain rate. We're able to measure the rate at which that snow falls. We want to talk about the accumulation here. Okay. This would be an example that we could probably actually do by hand as opposed to a calculator. As you can see, the difference is that we're given a table as opposed to an actual function. This is consider the concavity of RT and use it to determine an upper and lower bound for the total amount of snow accumulation over the course of 6 hours. So what I'm going to do is I'm going to draw a gentle graph of what I see here. At 0, I have 0. At 1, I have 0.1. At 2, I have 0.3. 3, I have 0.6. 4, I have 1.2. 5, I have 2.4. And 6, I have 4.8. So I'm just going to draw a curve that might fit that model. And it says to find an upper and a lower bound. Here's where you got to use your thinking cap, folks. If I want to find the upper bound, would that be accomplished by doing a right-hand sum or a left-hand sum? Why? So if we talk about this section right here, now right hand doesn't always give you an overestimate. It depends on the concavity of the graph. Right now, this is concave up. And if you were to draw a rectangle, a right rectangle, you can see that it is an overestimation, correct? So the upper bound will come from a right hand, and we will do 6 rectangles. And then the lower bound will come from a left-hand approximation of 6 rectangles. Well, what's the width of each rectangle? 1 times, where do I evaluate the first height? Okay, all right, let's pretend you can count. Where do you evaluate the first height? And you get 0.1 plus 0.3 plus 0.6 plus 1.2 plus 2.4 plus 4.8. And I get, let's see, that gives me 1 and 1.2 is 2.2, 4.6. Did you say 9.4? 9.4 what? Inches. What would change if I did the lower? I get rid of 4.8 and I pick up 0. I pick up 0, I get rid of 4.8. So 0 plus 0.1 plus 0.3 plus 0.6 plus 1.2 plus 2.4. And again, I get what? 4.6. So that means that we've collected at most 9.4 inches, and at a very minimum, we've collected 4.6 inches. Would you agree? Okay, then we go on the next part. It says, let S of 0 equal 2.4. What does that mean? You got 2.4 inches of snow at the beginning right away. Use T4. What does that mean? Trapezoidal of 4 to approximate the amount of snow coverage at 4 hours. So how would I do that? How many rectangles? 4. If I want to do trapezoidal, I have to do right hand of 4 plus left hand of 4 and divide that by 2, right? Okay, quick on your own. See if you can do right hand 4 and left hand 4 and divide by 2. Go. Okay. Somebody, what'd you get for R4? Yeah, right hand of 4 should be 2.2. What's L4? Should just be 1 divided by 2. So we got 2.2 plus 1 is 3.2. Divided by 2, which is 1.6. So approximate the amount of snow coverage at time equals 4, 1.6 inches, correct? You have to add the 2.4. So what I did is, in order to get 2.2, I did the right hand of the first 4. In order to do the left hand, I did the left hand of the first 4. If I add those up, I get 2.2. If I add this up, I get 1. I divide by 2, I get 1.6. Now, again, that's a mistake that you make. You get 1.6, you say you're done, but you have to add to that your starting, which is going to give you 4 inches. There's 4 inches of snow coverage on the ground. What? Okay, the width is only 1. So let me write it out one more time, okay? Okay. All right. Use the table to approximate r prime of 3 and r prime of 4.5. What does that mean? What does r prime mean? Finding the derivative. Now, the fact is that do we have a nice formula that we can just find the derivative of here? So we're going to approximate it. So in order to approximate it, we're going to do an average rate of change. So we're simply going to find slope. So I would like to find the slope at this spot, okay? I would like to find r prime of 3. Okay, now we did this earlier in the year, but if I want to find r prime of 3, okay, consider this. I want to find the rate of change at time 3. Are there 2 points that I could connect that would provide a slope that's about the same as that? If I consider the slope from 2 to 4, that should approximate the slope at 3, right? Might not be perfect, but it should approximate it. So in order to do that, I will take r of 4 minus r of 2 over 4 minus 2. What is r of 4? 1.2. What's r of 2? 0.3 divided by 2. 0.45 what? Inches per hour squared. Look at the next one. We want to approximate r prime of 4.5. If you want to approximate r prime of 4.5, what 2 points could you look at? What 2 r values could you look at? Yeah, you could look at from 4 to 5. So in order to approximate that, I'm going to do r of 5 minus r of 4 all over 5 minus 4. What's r of 5? 2.4 minus 1.2 all over 1.2 what? Very good. Okay, last question before we move on to the last part. Look at this question. It says, what does 1/4 integral 1 to 5 of RT dt mean? The average what? The mean value of the function. What is the function in this problem? Does the function tell us the amount of snow or the rate of the snow? It tells us the rate. So the function tells us the rate. So this will give us is the average value of the rate at which the snow is falling. First time I went through an AP exam, I left my answer like this. I got it incorrect. From time equals 1 to time equals 5. You have to talk about the actual bounds and what they mean in context of the problem as well. Yeah. See the difference? When you get to the AP exam, some people ask, well, how do you ask a free response question in the AP exam? This is almost exactly like one of the free response questions you get on the AP exam. The 3 examples I'm showing you right now could be pulled straight from an AP exam. Yep. Okay, we have one more. flip it over, and this time, instead of being given an equation or instead of being given a table, we have a picture. All right. C prime of t, this is t, this is C prime of t. C prime of t, be the line graph below, let it represent the rate at which customers are being served while purchasing music on an online store where C prime of t is measured in customers per minute. People are purchasing music. This must be a made-up problem because nobody purchases their music anymore, right? Very good. What is an overestimate for the number of customers served over the course of the first 8 minutes? And what is an underestimate? How would I come up with an overestimate looking at this graph? What would give me an overestimate, a right hand or a left hand? A right hand. So let's have, I'm going to divide you guys right here. So we're going to divide Kevin and Olby onto one side. Why don't you guys compute R sub 8? Okay. And the underestimate, everybody to the other side. Why don't you guys compute L sub 8 and see if you can come up with the over and the underestimate. Notice that we have 1, 2, 3, 4, 5, 6, 7, 8. So the width of each rectangle will simply be 1 in this scenario. Quick come up with the over and underestimates. I'll say the tick marks go up by 1 for the Y values as well. Okay, who got R sub 8? 22.5 approximately? Anybody want to contest that? Okay, anybody come up with L sub 8? 17.5. So 22.5 what? What are we collecting here? Customers. So our upper bound is 22.5 customers. Our lower bound is 17.5 customers, okay? All right, look at B. B says, what is the average rate at which C double prime of t is increasing? Oh my gosh. How does C double prime of t compare to the function that we are given? We're looking at the derivative of the function. Are we looking at the instantaneous rate of change or the average rate of change? What do we do to compute average rate of change? Slope. So we find C prime of 8 minus C prime of 0 divided by what? 8 minus 0. What is C prime of 8? 5 minus 0 over 8. 5 over 8. What is the label? Customers per minute squared. Because you're looking at the rate of the rate. See that? Okay, final question, and you are done for the day. What does 1/8 integral 0 to 8 C prime t dt mean? Use units in your explanation. Calculate the exact value of this. What I want you to do right now, take 1 minute and see if you can answer the first part. Write it down as best as you can, okay? Write down as best as you can what you think that means, and then I'll write down what I got, and then we'll calculate it exactly, okay? Go. I don't know if you really need to put the minute in there or not. I haven't seen the results of the free response section here, so I don't know for sure, but I'll check it out. So here we have it. You should have something of this nature. 1/8, 0 to 8, C prime t dt is the average value. Or you could just say the average rate at which the customers are being served. Either one would be fine. Okay. From time equals 0 to time equals 8. Okay. Actually, can I use yours as an example? Okay. Which customers are being served. Yeah, no, that'll be fine. That'll be fine, I think. Okay. Finally, let's check, let's calculate the exact value. Okay, so we're going to take 1 over 8 times, what is the width of each rectangle? If we want to calculate this, we got to simply find the area, right? Can we find this area? Yeah, we can find this area. It's no big deal. Let's just take 1/8 times this whole area, okay? I'm going to divide it up here. We're going to do this easy. I'm going to take, I'm going to look at these boxes right here. What do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We good with that? So we have 1/8 times 20, which is 20 over 8, or divide by 4, we have 5 over 2, or 2.5 what? Customers per minute. Because it's the average value of the rate function, so we leave it as a rate. Letter B, that's the second derivative. Okay? This is asking for the average value of the rate function. The rate is measured in customers per minute. This is double prime, so therefore customers per minute squared. The rate at which the rate is changing. Okay, you guys have your worksheet right in front of you? There you go.